In this presentation, we're going to look at box plots. Now, I'm quickly going to talk about what box plots are, just in case you're unfamiliar with them. And then we'll show how to implement them with R. Now, so they're used to depict the distribution of a numeric variable. And you sort of look at it and sort of see if a variable is skewed or symmetric or not, or if it's got any outliers. Just to make a sort of quick summary of that. It's also quite good for intergroup comparisons. For example, the numeric variable, the distribution of one subgroup versus another subgroup, something like that. Boys versus girls, test scores, or something like that. So the box component is the central component of this plot, and it's comprised of three parts. So essentially a box, and it's orientated on the number line. The lowest number, Q1, is where you draw the first of your vertical lines. It's a bit hard to tell here, but once we start doing this with R, we'll sort of go through it again. It also has the upper bound of this box is Q3. So that's the first and third quartile, or the 25th and 75th percentile. So which is, say, 25% of the values should be less than Q1 and 75% less than Q3, with the other 25% greater than Q3. So the box is sort of used to represent the middle 50%. Now, when the median is depicted with a line drawn through this box. Now, this is an important part here. At either end of the box are the whiskers, which represent the extremities of the data. Now, and a very important point there is that they do not necessarily represent the maximum and minimum. There's a sort of, you just sort of see it coming up here shortly, that we have a little sort of test for outliers. Not a formal test, hypothesis test, but a very simple metric, a very simple test to determine whether a value is an outlier or not. A box plot outlier anyway. Specifically, these values are where we draw our whiskers, is what we're particularly interested in right now. These are the highest and lowest values in the dataset that are not considered outliers. How do you know if a value is considered an outlier? Well, any observation that is less than Q1 minus 1.5 times IQR, that's the interquartile range, which you can calculate there, have it there. Recall IQR equals Q3 minus Q1. It's the difference between the two, numeric difference between quartile 1 and quartile 3. That's the interquartile range, and it's used in both of these calculations. Q1 minus 1.5 times IQR. So let's say Q1 is 30 and IQR is 10. And so we have 1.5 times 10 is 15, and Q1 was 30. So Q1 minus 1.5 times IQR is 15. So that would supposedly any number less than 15 would be an outlier. That's just a sort of quick numeric example I came up there. Likewise, Q3, any value greater than Q3 plus 1.5 times IQR, sort of this, the other end of the scale, the other end of the numeric range. Any values outside those thresholds are considered outliers, and they're sort of indicated separately on the box plot. Now I'm going to go down here, and this is a HTML document done up in R Markdown. So we're particularly interested, and I've gone just a bit too far there, is the syntax. Now, very simple command. How do you draw a box plot? Well, it's simply boxplot. Specifying the name of the variable, and you can also compare multiple groups by additionally specifying a grouping variable. So if there's some grouping variable in the data, that would help. So some categorical variable that you could group by, that's how you go about it. So suppose we have a numeric variable, which I've just given a very long name just to be as descriptive as possible. Usually people say X or Y. So I'm just sort of saying it's a numeric variable. Boxplot can just specify the name of the numeric variable. But also, if you want to have this grouping structure, you can have numeric variable tilde, and with my laptop anyway, the tilde sign is a little squiggle, little wavy hyphen, And on my laptop, it is just it's on the same key as the hash symbol, which we use for commenting in R. So it's on the right hand side of my keyboard, just beside the return button. So that's how you would sort of make that little symbol there. It's a little wavy hyphen. So it's probably a bit hard to tell. And the grouping variable. Now, anyway, our box plot. The default orientation is vertical. And you can actually specify horizontal orientation. This is just my little bit of my markdown has gone here, but I'll just show you anyway. I'll keep going anyway. You can also add a little title to the plot. Now, so for example, we could use a data set that is inbuilt in R, and I'm going to use the empty cars data set. And there's a numeric variable, numeric column. There's a numeric variable which is one of the columns of MT cars, and it's MPG, miles per gallon. Okay. And so what I'm going to do is construct a little box plot, and I'll just go box plot MPG. Now just to be clear about something, I've attached MT cars already, so I don't have to say MT cars $ miles per gallon, just in case you're sort of wondering about that. And also just put a little box plot there, box plot simple implementation. So that's what it would look like there. Very big. I'll sort of try and make the screen a little bit smaller for a second, so just so you get a proper sense of what you should be looking at. The font there. There we go. That's our little simple implementation. I'm going to make a big screen again. Make it easy to read. Just as a quick remark, actually, if these videos are best watched in full screen mode on YouTube. Now, suppose I want a horizontal orientation rather than vertical orientation. For me, horizontal would be my preference. And so there we have. All we have to do is add in the additional argument horizontal equals true. And this is what our end result looks like. This is the only sort of difference I've made. There we have it there. And again, I'm out this little bit smaller just to make it a bit more legible there. Now, so I spoke a bit earlier on about Q1, Q3, and outliers and stuff like that. Now, so let's just actually, now that we have it in front of us, let's look at this again. So here's our box. Okay. So around, let's say, I'm guessing around 16 or probably 15 and a half is Q1. Our median, well, we could check it off the summary anyway, but just like this line here, I'm making that 19 and about 23. So this is our box here, and this depicts on the number line, which is the number line down here, 10, 15, 20 and so on. This depicts the range where the inner 50% of the values are, and it also tells me where Q1, Q2, the median, and Q3 are. Here we have the whiskers on either end, so this is the lowest value, not an outlier, and this is the highest value, not an outlier, on the other side. Now, there are also the maximum and minimum of the data set. Now, the reason I know that is because there's no outliers, there's no little asterisks or little circles just beyond. So if those were there, if those were present, they're not present in this example, they would be considered box plot outliers. Okay. Now, so that's just a bit of revision on box plots and stuff like that. Now, we can actually color in our box plot. I actually like when we have our box plots colored in. Just looks prettier. Now, all we have to do is additionally specify call equals whatever color you like. I like light blue. No particular reason. There we go. You can go for hot pink. So that's our box plot there colored in. Okay. Just bear with me a second. Let's get myself back to normal. There we go. And it's just going a bit too far there. And we can also okay, so what I said earlier was that we could have a grouping variable. Now in this data set, we have miles per gallon, and there's another variable that is dichotomous. It's a categorical variable, and it's AM. That sort of stands for automatic and manual. And there are sort of two levels of this variable, 0 and 1. It's a factor, okay? So 0 for, let's say, automatic, 1 for manual. So what we have done is we sort of split up the data into two box plots, one for the zeros and one for the ones. And what we can do here is use this to sort of compare and contrast the miles per gallon for the two groups. So we have light blue up on top, that's for the ones, and dark blue underneath, that's for the zeros. Now just as a remark, how do we specify color blue, light blue? Just specify it as a vector essentially. But miles per gallon tilde AM. That's all we have to do there, just to sort of specify it as two different variables. And I'm just going to make that a bit smaller again, just so you can see it properly. There we go. And so that's the tilde symbol. And I'm just going to do one quick example more, just so we can have a look at just working with a different variable. I'm just going to make that smaller again. So I'm going to work with miles per gallon grouped by the cylinder types. Okay, so we have 4 cylinders, 6 cylinders, and 8 cylinders. And the 4 cylinders are colored in blue, obviously very high miles per gallon. The 6 cylinders, not as good in terms of miles per gallon, they're a bit lower than the number line. The 8 cylinders, the lowest of the lot. But essentially what I was sort of going to get a remark upon here is this little dot here, and this indicates that on this box plot we have an outlier. Okay, and that's the point of that one. So anyway, that's enough about outliers. We're going to sort of call it a night, and I'm going to switch this off. There we go, 12 minutes.